In a recent video, I demonstrated how z-scores can actually hide outliers, particularly when the data set is small. And so since we're football season, let's replay the tape. And then I want to demonstrate a different strategy for looking for outliers when your data set might be small. Let's talk about z-score. A z-score value is a simple measurement that tells you how far a particular number is from the mean of your data set. So if you consider a map of downtown or a city layout, and let's say the mean is our downtown location, and as we move further out from the mean, we get a larger z-score. We might be moving into the suburbs, and we can call that location an outlier. So let me show you what this looks like graphically. Here is a normal distribution with the z-scores overlaid. This z of 0 is the value that's equal to the mean of our distribution. And as we move further and further out from the mean, we are approaching points that would most likely be outliers, especially as we get past a z-score value of 3. And with a tool like Python, it's really easy to compute the z-score value of numbers when we have our data set. Before we go into the code, one of the important observations from this distribution is that it assumes 1, a Gaussian or normal distribution, and 2, when you start introducing outliers into the data set, they can begin to shift the mean. And thus, if you have a small number of measurements or replicates, outliers could be very difficult to spot because of this shifted mean. And this is what plagued our small data set when we had 10 samples where the average was about 10. And then we added an outlier where the value was 150. And even being an order of magnitude greater, the z-score approach failed to identify this outlier because of this shifted mean and the assumptions built into the equation. And so in this video, I want to demonstrate a modified way, a more robust way for identifying outliers that relies on the median versus the mean. Let's get started. To refresh you what we did before, we had a data set and we used the SciPy stats module in order to compute the z-score. And when we had a value of 150 in our data set, we failed to identify the outlier because of this shifted mean. So our mean was 10. And now the mean is 23.5 because our data set's so small. In that video, I increased the sample size to 20, and this was sufficient for identifying an outlier in that data set. And now I want to demonstrate a more robust way for identifying outliers when you have a small sample set. To do that, we're going to now use the robust module from stats modules, and I'm going to compute the median instead of the mean. The median is known to be more robust against outliers. Next, we're going to compute the mean absolute difference, which we can call from the robust module using this .mad method on df values. And this is just another way to estimate the spread of our data set by looking at how far each value is from the median of this data set. Next, I'm going to compute a modified z-score by subtracting the median from each of the values and then dividing by that mean absolute difference. And then in order to put this on the same scale as a traditional z-score measurement, we're going to multiply times 0.6745. Next, I'm going to add another column that's called is outlier modified, which is going to look for the values that are greater than our cutoff, which typically for the robust z-score is 3.5. And then I'm going to display that data frame. As you can see here, I have my traditional z-score and is outlier, which was from the first video. Then I added the modified z-score, which is using this robust approach, and the is outlier modified. And we can see that for sample number 2, where we have our outlier value or our anomalous value, it is missed here in the traditional z-score. But when we use our modified approach, it is getting flagged even with this small data set. And this is important because if you know your data might have some skew and you can't quite correct the signal, you can use this approach or at least have it as part of your arsenal for helping your team understand the data they have. And this is all accessible using Python. If you have any questions, leave them in the comments below. And also let me know what types of techniques you use to identify outliers, particularly if you have a small data set and can't easily acquire more data. In any case, I'll see you in the next video. Peace.